Okay, so we're just going to start right here with example 5. Find the number of terms of the finite arithmetic sequence 7, 3, -1, -5, and so on up to -113. So basically, when it says to find the number of terms, it means what is this term right here, because that's the last term. And so if we know what term number that is, we'll know how many terms are in this sequence. So since this is an arithmetic sequence, we know that any term in the sequence can be written as a sub 1 plus n minus 1 d, where n is the term number and d is the common difference. So we can see for this sequence that the common difference is just -4, because every time you go from one term to the next, you subtract 4. If you take a term like 3 and subtract the term before it, you get -4. If you take -1 and subtract 3, you get -4. If you take -5 and subtract the term before it, you get a -4. And so we can see the common difference is -4. All right. Now, all we have to do is put that information into this equation for an arithmetic sequence, and we'll figure out what term that -113 is. So -113 is a sub n. We don't know what term it is, but we know its value is -113. That should equal a sub 1, which is 7, the first term, plus n minus 1 times -4. Now, n is the thing we don't know. We don't know what term is this. It's the nth term, but what is n? And that's what we can now solve, because that's the only unknown in this equation. So -113 is equal to 7 plus -4n plus 4. And if we subtract 11 on both sides, we'll have -124 is equal to -4n. So n is going to be 31. And so that means that there are 31 terms in this sequence. Okay, for an arithmetic sequence, a sub 15 is 49 and a sub 27 is 85. Find the 500th term. All right, so a couple things we need to find out here. We need to find out what the common difference is. We need to find out what the first term is, because if we know those, we'll be able to find the 500th term, because since it's an arithmetic sequence, a sub n is equal to a sub 1 plus n minus 1 times d. So we don't know d, and we need to find it. We don't know a sub 1, and we need to find it. But we know two terms, which means we'll be able to write two equations with two unknowns. So we know a sub 15. A sub 15 is 49, and since it is a sub 15, it's going to be a sub 1 plus n minus 1 times d. And in this case, since a sub 15 is what we're looking at, that n minus 1 is 14. So 49 is a sub 1 plus 14d, because that's the 15th term. A sub 27, that's the 27th term, and that equals 85. So that is going to equal the first term plus 26d, one less than 27. So I've got two equations right here in two unknowns, a sub 1 and d. If I solve this system of equations, I can find out what a sub 1 and d are. So now if I subtract those two equations, the a sub 1s are going to cancel out, and I'll just have -36 is equal to -12d, which means that d is 3. So I've got my common difference. That's d, that's 3. And I can plug that back into either one of these equations to find out what a sub 1 is. So I'm going to plug it back into the first equation. 49 is equal to a sub 1 plus 14 times 3. So that means 49 is equal to a sub 1 plus 42. So a sub 1 is going to be 7. So the first term is 7. Common difference is 3. And that means that the 500th term, a sub 500, is going to equal a sub 1, which I now know is 7, plus 499 times d. And if I multiply that out and add it up, that's going to be 1504. Okay, so an arithmetic series, remember I said, is when you add the terms in an arithmetic sequence. So as stated earlier, the sum of the first n terms of an arithmetic sequence is called the nth partial sum, and is denoted by s sub n. It is said that at the age of 7, the famous German mathematician and math prodigy Carl Friedrich Gauss amazed his teachers by adding up all the integers from 1 to 100 in a matter of seconds. So let's try and see if we can add up the first 20 integers in a matter of seconds. We can if we figure out how to do it, if there's an easy way to do it, if there's a pattern that emerges. And since you're not here to tell me, I will go ahead and tell you that if you wanted to add these up the way Gauss added the first 100 integers, you would notice the pattern that if you look at the first digit, the first term, and the last term, they add up to 21. And if you notice the second term and the second to the last term also add up to 21. And the third term and the third from the last term also add up to 21, and so on. And so you can make these pairs that all add up to 21, starting from the outside and going toward the inside. If you have 20 numbers and you arrange them in pairs, you will have 10 pairs because there'll be 2 numbers per pair. So you've got 10 21s that you're adding up here. And so 10 times 21 is equal to 210. So we can add that up really quickly using that pattern, noticing that pattern. That pattern holds for every arithmetic series. That is, you can add the first term plus the nth term, and you can multiply that by the number of terms divided by 2, and you will get the sum of that series. So S sub n is equal to n over 2 times a sub 1 plus a sub n. That always works for any arithmetic sequence. It is the nth partial sum of that sequence. So if we wanted to find the sum of the first 50 terms of this sequence, even though the numbers are now separated by 2, it doesn't matter. We just have to know a sub 1, the first term. We have to know a sub n, the term that's going to be the last term we add up. And we have to know n over 2, and we can figure out that nth partial sum. So find the sum of the first 50 terms. So S sub 50, we would call that the 50th partial sum, is going to equal 50 over 2 times a sub 1, which we can see is 2, plus a sub 50. What is a sub 50? Well, there are several ways you could figure that out. You could notice that every term is just double the term number. So the first term is 1 times 2. The second term is 2 times 2. The third term is 2 times 3, and so on. So you would know that that 50th term is going to be 2 times 50, or 100. Another way you could figure that out would be to say, okay, it's an arithmetic sequence. So a sub n is always equal to a sub 1 plus n minus 1 times the common difference. I know the common difference for this sequence is 2, because if you subtract 4 minus 2, you get 2. 6 minus 4, you get 2. 8 minus 6, you get 2. 2 is the common difference. So if I'm trying to find a sub 50 for that sequence, that's going to be a sub 1, which is 2, plus 49 times d, which is 2. So a sub 50 is 2 plus 98. So that is going to be 100. So I know that the 50th term is 100, and that's what needs to go right here. That's the nth term. And since we're looking for the 50th term, that would be 100. So got that. And we just figure it out. 25 times 102 is going to give us 2,550. So that is the sum of the first 50 terms of 2, 4, 6, 8, 10, and so on. If we want to find the sum down here, the sum from 1 to 60 of 3i plus 5, we could either go through every single term and add them up, or we could just think about this as a sequence. All right. The first term is going to be 3 times 1 plus 5, which is 8. The second term would be 3 times 2 plus 5, which would be 11. The third term would be 3 times 3 plus 5, which would be 14, and so on. And you can see that that is an arithmetic sequence where you just add 3 every time. So the 60th partial sum, if I want to add up the first 60 terms of this sequence right here, I know how to do it now. S sub 60 is equal to 60 over 2 times the first term, which is 8, plus the nth term. And since n is 60, 60th term is the last term of this sequence that I'm going to add up. I know that it is just 3 times 60 plus 5, which is 185. So that goes here. And that is going to be 30 times 193, which is 5,790. Suppose that a job offers a starting salary of 75,000 with a raise of 4,000 every year thereafter. Write an expression for the nth term of an arithmetic sequence that represents the salary as a function of the number of years of employment, n. So it's an arithmetic sequence. You add 4,000 every time. So A sub n is equal to the first term plus n minus 1 times d, which in this case is 4,000. You add 4,000 every year. And so A sub n is equal to 75,000 plus 4,000n minus 4,000. So A sub n can be written as 71,000 plus 4,000n. That is a way to write the nth term of this sequence. Part B, that was part A. Find the total income for an employee who works at the job for 20 years. So now I'm trying to find out the 20th partial sum for this sequence of salaries. And so the 20th partial sum, I'm going to add up the first 20 terms of this sequence. That's going to be 20 over 2, n over 2, times A sub 1, which we know is 75,000, plus the final salary, which will be the salary at 20 years. So I've got to figure out the salary at 20 years, which is A sub 20. So A sub 20 is equal to 71,000 plus 4,000 times 20, and that's going to be 151,000. So that is my A sub n, or my 20th term. So 151. And now I just multiply this out, and I'll have 10 times 226,000. And if I multiply that by 10, I have 226, 1, 2, 3, 4 zeros. So 2,260,000.